Hello everyone, welcome back. So this time we want to talk about the fundamental theorem of calculus. Okay, up to now in calculus 1 class, we just talk about indefinite antiderivative property and then we find out that. Okay, this time we are learning finite integral case. So basically this fundamental theorem means we are making closed interval and find the area of the region. Okay, one example. So I drew the random graph here, and then let's say just make some interval a and b. Okay, now this is given fx. If you integral this fx, then you can find out the area region between a and b. That's what this means basically. So if we write it, so let's say integral fx dx, we can define as a fx, then this becomes basically fb minus fa. Okay, so that's the property to find the area of this region. Make sense to you? Okay. Then let's look at one example and then we continue to discuss this topic. So evaluating a definite integral. So evaluate each definite integral. So look at a first. So we're doing integral 1 to 2 x cubed minus 3 dx. Okay, so the first step is you temporarily ignore this interval value and then just antiderivative this expression. Okay, but let's do so. Then you will get x cubed over 3 minus 3x plus c, right? Okay, but now this is not indefinite integral. We are just a finite interval value, so you don't need to see anymore. Instead, you are finding value between close interval 1 to 2 basically. Okay, and now next step is you are plugging 2 into here first, minus later you plug 1 into this x. That's kind of two different steps. Okay, so I'm gonna do it. So first of all, you plug 2 into x's, then 2 cubed over 3 minus 3 times 2 minus 1 cubed over 3 minus 3 times 1. Are you with me? You know what I'm doing here? Yeah. Once more, I plug 2 into this x's first. That's how I got this one. And then I plug 1 into both here, then I got this one basically. Okay. Then now last step we simplify. Okay, so this becomes 8 over 3 minus 6 minus 1 over 3 plus 3. So it becomes 7 over 3 minus 3, which means negative 2 over 3. Oh, now let's look at this value carefully. Can we have negative area value? Actually, it is not. However, in calculus class, it is possible. Okay, then we need to know what this means. Okay, you know, this means I just randomly drew the graph of the x squared minus 3. Then I can make somehow like this. And then now we are doing between 1 and 2. So 1 and 2, you are making basically area for this region. And you see that this area is under the x-axis, right? X-axis. So even though we are doing area value, this is also function form. So whatever the area value locate under the x-axis, then we got negative area value. Then what about, the same thing, but just in case, I'm going to draw it like this, and then 1 and 2 here, and then we go like this. Yeah, then this area value must be positive because the region is on the x-axis. Okay, so that's difference here. So even though you got negative value, don't be freaked out. This means just implies that the region is on the axis. That's why I got negative area value. That's all. Okay, then let's continue second question here, which is 3 root x. So integral 1 to 4, right? 1 to 4, 3 root x dx. Okay, so this one now I can do. So 3 times x 1 over 2 plus 1 becomes 3 over 2 over 3 over 2, right? And then we are doing between 1 and 4. Okay, let's simplify that. Then I can see this and this canceled out, so 2x 3 over 2 to the 1 to 4. Okay, that's how I got. Okay, then from here now I plug 4 into x first, and then now I'm gonna put 1 to x later, and we find difference. So look at here. So this becomes 2 times 4 to the 3 over 2 power minus 2 times 1 to the 3 over 2 power. Okay, then this means 2 times 2 cube minus 2 times 1. Therefore, this become 2 times 8, so 16 minus 2, so equal to 14. So this implies that the region is on the x-axis, so that we got the positive area value. And simply, if I show that graph shape, then somehow it become like this, and then 1 to 4 here. So this region, area of this region become basically 14. Make sense? That's what this means. Okay, then let's look at the third one here, which is 0 to pi over 4 secant square x dx. So 0 to pi over 4 secant square x dx. Okay, so you got the secant square x dx. What's the antiderivative secant square x? Yeah, that must be tangent x, right? Okay, so this become basically tangent x 0 to pi over 4 basically. Okay, so of course we better just input 0 and then the value automatically. That will be good, but sometimes it can be really confused. So I'm going to rewrite tangent as a sine and cosine value. Then this becomes sine x over cosine x to the 0 to pi over 4. Okay, which means now we can do sine pi over 4 over cosine pi over 4 minus sine 0 over cosine 0. Okay, so this becomes, the sine and cosine value are the same, at the radian value pi over 4, right? So this becomes 1, and minus sine 0, 0 becomes 0, cosine 0 becomes 1, so 0 over 1 becomes 0. So answer becomes basically 1. Okay? The same thing. So if I drew the graph here, so 0, so pi over 2, it becomes something like this. And now we are making 0 to pi over 4. So this angle value become 1 basically. And then we double check that this region is on the x-axis. That's why we got the positive value. Okay? So that's all this video. And then I will see you later. Bye.